Good morning, friends. Today we are going to continue with the lesson on the number system. But before I do that, I would like to apologize you for yesterday. In yesterday's video, there was some audio error. Now it's a digital world, and a digital world has got digital problems. Yes, I hope you agree with me. Digital world has got digital problems, but to revise what we did yesterday is a few sums to show that any non-terminating decimal, non-terminating recurring decimal can be written in the P by Q form. So non-terminating recurring decimal is a rational number, and then we did the division method. The audio was not clear, but I hope you could see the video clearly. I used the division method to find square root and showed you that the division of the square root, yes, so finding the square root by division, we got a non-terminating non-recurring decimal. Now because we got a non-terminating non-recurring decimal in square root, we figured out that numbers like root 2, root 3, root 5 are irrational numbers. Again, they are irrational numbers because when converted to decimal form by the division, yes, the decimal form is a non-terminating, non-recurring decimal. But we saw that even the irrational numbers can be represented on the number line. Irrational numbers can also be represented on the number line. How did we represent them on the number line? By using the Pythagoras theorem. Yes, in the textbook you will see a spiral method that is also very easy, and using the Pythagoras theorem, and I had given you some sums for homework yesterday. So I hope you have done those sums. So yesterday we had seen that on the number line we represent natural numbers, whole numbers, integers, rational numbers and irrational numbers. Yes, so that was the number system we did till yesterday. I want you to go to the textbook exercise, try out the sums. If you have got any doubts, I told you before, you can always contact me. Today we'll take a view at the spiral method. Yes. So what is the spiral? We take 1 unit and 1 unit. So this is 1 unit and 1 unit. 1 square plus 1 square equal to 2. This is using the Pythagoras theorem. So we get this distance. So this distance is the distance square. So the distance is root 2. So this distance we get root 2. Using the Pythagoras theorem. Now we continue with the spiral. How do we continue with the spiral? This was 90 degree. Now exactly at right angle, construct 1 unit more. And again use the Pythagoras theorem. So what is this distance now? Root 2. So root 2 the whole square plus 1 square. Now what is root 2 the whole square? So I hope you know the multiplication of irrational numbers. Root 2 into root 2 is root 4. But what is root 4? Root 4 is 2. So we get 2 plus 1 as the d square. So d is equal to 2 plus 1 is 3. Taking the root 3. So now this distance is root 3. Similarly, again at 90 degree you take 1 unit, you will get this root 4, or root 4 is nothing but 2. Then again you go 90 degree, you will get root 5. This is called the root spiral. Yes? So this is what is the root spiral, which we do by the construction method. Yes? So I hope you are clear till here. Once again I tell you, we can represent all the rational numbers and the irrational numbers on the number line. And the rational numbers and irrational numbers together are called real numbers. But that is the topic for the next year in the 10th standard.
Right now we only relate to the irrational numbers. Now let us see some mathematics of the irrational numbers. Now is it clear to you? You can see the whole board. So what I have done is found out the distance. How I found out root 2, root 3 and root 4. So a little bit was cut from the board. Now I have adjusted it properly and I think you can see clearly. Moving further now, since we have understood what irrational numbers are, so I will write irrational numbers on the board a little bit. Root 2 is a irrational number, root 3 is a irrational number, root 7 upon 2 is a irrational number, 3 upon root 5 is a irrational number. Now why are these numbers irrational numbers? Because root 2 gives me a non-terminating, non-recurring decimal. Root 3 gives me a non-terminating, non-recurring decimal. Root 7 gives me a non-terminating, non-recurring decimal. So even when I divide by 2, it still remains a non-terminating, non-recurring decimal. Here, the denominator is irrational. This is a non-terminating, non-recurring decimal. So when you divide 3 by root 5, you will still get a non-terminating, non-recurring decimal. So these numbers are all irrational numbers. Yes? So once we have understood irrational numbers, now what do we do with numbers? You had natural numbers, whole numbers, integers, rational numbers. So in the previous classes, what did you do with the numbers? You did nothing but mathematical operations on those numbers. So you remember, I told you before, why we put the whole world into numbers? Because of numbers, you can do mathematical operations. Now, which are the basic mathematical operations that we know? The basic mathematical operations that we usually do are what? Addition, or subtraction, or multiplication, or division, or finding the square, or finding the cube, or finding the square root, or finding the cube root. All these are mathematical operations. So you know how to add natural numbers, whole numbers, integers, rational numbers. Finding the squares, cubes, square roots, cube roots of natural numbers, whole numbers, integers and rational numbers. Now we have to do the same mathematical operations on irrational numbers. So how will we add? We can add two irrational numbers, or we can add a rational number and an irrational number. So now we'll go through the mathematical operations and find out what is the general pattern we are getting. So I will continue by writing a rational number. Let a be 2 upon 3. Now 2 upon 3 is in the p by q form, so it's a rational number. And b I will write root 7. That is the irrational number. This is in the p by q form, a non-terminating recurring decimal, and this is a non-terminating non-recurring decimal. Now do the operation and see. When I do a plus b, I get 2 by 3 plus root 7. What is 2 by 3? 2 by 3 is 0.66 and so on. So 0.6 bar. Right? But what is root 7? What we have root 7? The value is 2.6457, and these values are not recurring. Because they are not recurring, I cannot add this 2. I cannot do the addition. I can only get a rough approximation, but I cannot do the addition. So on addition of a rational number, yes, a rational number, I will write q. Rational number with an irrational number, the answer I got is irrational. So on adding a rational number and an irrational number, I always get an irrational number. Same way, if I subtract, then 2 by 3, subtract minus root 7. Again you can see This is a rational number, a non-terminating recurring, but this is non-terminating non-recurring. This will also give me an irrational number. So we never solve this. We never solve these numbers. We only keep them in the irrational form. So this number is also an irrational number. Now we can try multiply. A into B is 2 into roots 2 by 3 plus root 7. So you know take out the LCM. It is 1. So into 3 into 3. So we get 2 plus root 7, sorry 3 root 7 upon 3. This is the form we write, but we still get this is a irrational number. And if you divide A by B, means 2 by 3 divided by root 7 upon 1. I write upon 1. When it goes up, it becomes 2 upon 3 root 7. So this is the form I write, and it is still an irrational number. So I have written here on adding, subtracting, multiplying and dividing a rational number with an irrational number, what I get is an irrational number. So the fact remains that on addition, subtraction, multiplication and division of a rational number with an irrational number, we get always an irrational number. Okay? So this is the general pattern that we have. That is why I told you that we never write. We can write this 2 by 3 into the decimal form at 0.6 bar, but root 7 can never be shown in the decimal form because it is a non-terminating, non-recurring, it is a long decimal. So we always write irrational numbers in this form only. When you add 2 by 3 plus root 7, keep it as 2 by 3 plus root 7. Sorry, I have to multiply here. I have done the addition. There's a mistake here. I should have done the multiplication. Right? So here I will have 2 by 3 into root 7 should give me 2 root 7 by 3. Kindly check this error. There was a small mistake here. Okay? So what I'm trying to tell you, when you add a rational number with an irrational number, you keep it in this form only. We don't simplify it further. Yes? The subtraction is kept as it is. The only subtraction, only simplification you can do is, you can take the LCM like I did there and write 2 plus 3 root 7 upon 3. And in this case you can write 2 minus 3 root 7 upon 3. We do not solve this further. You can see we keep them as it is. So this is the way of writing the irrational numbers. So this was the operation of a rational number with an irrational number. Now we'll try doing operations of irrational numbers with irrational numbers. Let us see what happens. Now I have put 4 irrational numbers on the board. A, root 2 minus 1, B, root 2 plus 1, C, root 2 and D, root 3. I have put 4 irrational numbers on the board. And you know very well why the irrational numbers, because root 2 is irrational. So we know that subtracting or adding a rational number with the irrational number always gives us an irrational number. So these 4 numbers are irrational numbers. Okay? Now let me add A plus B. I am adding A and B. So I got root 2 minus 1 plus root 2 plus 1. Minus and 1 plus 1 gets cut. So I get 2 root 2. So when I am adding these 2 irrational numbers, the answer is still irrational. Let me subtract A minus 1. So I have got root 2 minus 1 minus, I put the bracket here. Remember the bracket is important because the signs will change. So when I open the bracket, I get root 2 minus 1, the minus sign, so the sign change. Root 2 is positive becomes negative, plus 1 is positive becomes negative. Now here, root 2 and minus root 2 get cut, minus 1 is minus 2. So in this case, this answer became a rational number. This remained an irrational number, but this became a rational number. So you can see when you add or subtract 2 irrational numbers, then the answer can be irrational also and rational also.
Let us multiply a into b. A into b is root 2 minus 1 into root 2 plus 1. Now what is a minus b into a plus b? It is a square minus b square. Now what is root 2 into root 2? Root 2 into root 2 is root 4. But root 4 is 2. So 2 minus 1 gives me 1. Again, on multiplication it became a rational number.
So you must have followed this, that in mathematical operations of two irrational numbers, we might get rational, we might get irrational. There is no fixed rule. Previously you saw that on addition, subtraction, multiplication and division of a rational number with an irrational number, the answer was always irrational. But in this case, when there are two irrational numbers, then the addition, subtraction, multiplication, division, the answer may either come rational or come irrational.
Okay, so I will do some more multiplications. This is a into b. Now what I will do further, let me multiply a with c. So I want to multiply a with c. So root 2 minus 1 into root 2, a into c. What is root 2 into root 2 again? Root 4. So root 4 is 2 and minus 1 into root 2 is minus root 2. Again what do you see? This is an irrational number.
So multiplication of an irrational with an irrational sometimes give me an irrational number, sometimes it gives me a rational number.
Let me multiply c into d. C into d is root 2 into root 3. That is root 6. It is still an irrational number. Is it clear to you? We'll multiply a into d. A into d is, sorry, let us multiply b into d. B is root 2 plus 1 and d is root 3. So how do you open the bracket? 3 into root 2 is root 6 and root 3 plus 1 into plus 1 is root 3.
So I hope you have understood here that the mathematical operations on two irrational numbers may yield a rational number or an irrational number. Now we are going to make use of this property for some further sums. Let's have a mental exercise. Yes? Can you think of some irrational numbers whose multiplication and addition gives me a rational number? I had done one example on the board for you. Can you think of one more example? Yes?
I will write one more example and you can check it out. That a is equal to 4 minus root 3 and b is equal to 4 plus root 3. Now look at these numbers carefully. The digits at both the places are same, only the sign is different. Can you see that? This you will learn in further classes. These are called surds. Remember the word surds. They are called surds or they are also called rationalizing numbers.
They rationalize. Both of them are irrational numbers. Can you see that? Both of them are irrational numbers, but they can rationalize each other. Okay? And rationalizing we only use multiplication. We don't use addition, multiplication.
So let me multiply a into b. So I get 4 minus root 3 into 4 plus root 3. Now,
A minus b into a plus b
is a square minus b square. What is 4 square? 16.
and root 3 square is what? Root 3 into root 3, that is root 9.
And root 9 is 3. Actually root 9 is plus and minus 3, but we take the positive number. So 16 minus 3 is 30. So the multiplication of these two numbers
Give me a rational number. So what we can say, b has rationalized a, or you can say a has rationalized b. So these are called surds or a rationalizing factor. This is what surds are. Okay? So is it clear to you? Because we are going to use this now. Now I have written some standard identities on the board.
So these are
Positive real numbers, yes, positive rational numbers. So root A into root B. Root A into root B, we write root AB. Yes, we have done this before. So, for example, root 2 into root 3 I told you is root 6. Yes, but I told you the simplification is difficult because root 2 is a non-terminating, non-recurring, root 3 is a non-terminating, non-recurring. So the answer will be non-terminating, non-recurring, but root 2 into root 3 is root 6 accurately. But again, we cannot prove this because they are non-terminating, non-recurring. We can only prove this through mathematical identities. Same way, root A by root B will be the root of A by B. So what does it basically tell you? You can see what does it tell you. It tells you that if you find the value of root 2, you find it is a non-terminating, non-recurring, and you will find the value of root 3. When you multiply those two, you will get the value of root 6. But we do not rationalize, we do not do the decimal, we only have taken this identity. So root 2 into root 3 gives root 6. Similarly, if you divide root 2 by root 3, root 2 by root 3, you can first divide 2 by 3. 2 by 3 is about 0.6 bar we said, and then find the square root will give us the same answer. So these are called mathematical identities. You have to remember this, will be very useful in your sums. So this is an identity chart. Write down this formula on a neat piece of paper and always keep this paper with you. You can pause the video for a second later on. I'll tell you again. A plus B into A minus B, or root A plus root B into root A minus root B is what? Root A the whole square minus root B the whole square. So what is root A the whole square? Root A into root A. You have got root A into root A, that is under root of A square. So the square root and square gets cut. So what do we get? We get A minus B. Now comes this root A plus root B the whole square. Now what was A plus B the whole square? A plus B the whole square was A square plus 2AB plus B square. Instead of A and A root used, so we have got A plus 2 root AB plus B. And the same formula works for minus also. The minus and the A square minus 2AB plus B square. So we get A plus 2 root AB plus B. Now the last is multiplying to irrational numbers. How do we open the brackets? Root A into root C is root AC. Root A into root D is root AB. Root B into root C is root BC. And root B into root D is root BD. And this sign is plus minus, so accordingly you have to see the plus minus signs. I hope I am clear till here. These are the identities. Now what I want you to do, I want you to pause the screen for a minute, take a neat sheet of paper and write these identities in that paper, and this paper you can always refer to while doing the sums. It will be handy, but as time progresses you will learn it and then it will become very easy for you, right? So now since we have done these topics, let us try out a few sums so you get a very good idea of how these things work. The first sum we are going to do is find the square of A plus 5 root 3. So what we have to do, we have to find A plus 5 root 3 square. Yes, square. Now write the identity. What is the identity? A plus B the whole square is A square plus 2AB plus B square. This is the identity I have written on the side. This identities you should be remembering because this is very important to solve the sums. Now using the identity, what you can see, compare. Compare this bracket with this bracket. So our A is 8. Can you see? If you compare, A is 8 and B is 5 root 3. Comparing, we got A plus 5 root 3 square, A plus B square. So our A is what? A is 8 and what is the B? B is 5 root 3. So when I write A square, I should write 8 square plus 2 AB. What is your A? Your A is 8 and what is your B? 5 root 3 plus
b square. What is your b? 5 root 3. So 5 root 3 the whole square. Now let us solve.
8 square is
64.
2 into 8 into 5 root 3.
So 2 8s are 16. 16 5s are, because this is which part? This is an irrational number made of two parts, a rational part and an irrational part.
So you can always multiply the rational part but not the irrational part.
So 2 8s are 16, 16 5s are 80. So we get 80 and root 3 is the irrational part, so 80 root 3.
Again, square.
What is 5 square? 5 square is 25. The rational part, the irrational part. Root 3 square is
Root 3 into root 3, that is root 9.
and root 9 becomes 3. So 25 3s are 75.
Yes, we got 75. Is it clear? Are you following?
So 64 plus 75. How much we get? 139. That is the rational part. I can add rational numbers. And the irrational part is 80 root 3.
So the square gives me the answer.
139 plus 80 root 3.
So what is the new part we got here?
When you are multiplying a rational number with an irrational number, only in multiplication, you can multiply the rational part, but the irrational part will remain as it is.
If it is the irrational part, you can even multiply the irrational part like we did in the previous example. For example, root 2 into root 3 will give you root 6. So these identities you have to understand very well. All the sums will be different. I told you before, you understood the rules. When you add, subtract, multiply, divide a rational number and the irrational number, the answer is always irrational. But on doing the same with two irrational numbers, the answer can be either rational or it can be irrational depending upon the sum. Let me tell you one more example. Let us do it.
Suppose I have got root 3 into root 12.
Now root 3 and root 12 both are irrational numbers. You see that? Root 3 and root 12 are irrational numbers.
But what is root 3 into root 12 is 12, these are 36. So becomes root 36 and root 36 is 6.
So here we have got, this as root 12 is what?
Root 3 into root 12 is 6. One more thing to consider here, this number 12. Yes? How do you write root 12? Now in the 9th you did prime factorization.
Remember prime factorization?
You break up this 12 into factors. 2 6s are, 2 3s are, 3 1s are. So root 12 can be written as root of 2 into 2 into 3. But this 2 and 2 form a pair. So you can take the pair outside the square root, so you get 2, and this does not have a pair, so we write root 3.
So 12 root 3 is also 2 root 3. Remember,
Root 12 can be also written as 2 root 3. They have got the same value.
so you can see these irrational numbers can be represented in so many different forms. You have to keep a quick watch on this, and by practice you will understand. So we have done this method of prime factorization in the 6th or the 7th standard. Then we saw how to find the square root of numbers. But here you see, in the 9th you only did what? The rational numbers. Here we have got an irrational number. So this irrational number, when broken down, gets a rational part and an irrational part. Okay? And don't have to worry, you repeat the video one more time, see it again, and we'll keep on practicing lot of sums. By doing the sums, this idea will become more thorough to us. In this sum, we have to find the product of these two numbers. One number is under root 3 by 5. Sorry, this is a mistake here.
This number is under root 5 by 2, and you have to multiply these two numbers. So we have learned an identity.
So first we'll use the identity and simplify this number. How can I write this number?
This number can be written as root 3 upon root 5, and this number can be written as root 5 upon root 2.
So I have not made any change. I have just simplified this number. And the other number to multiply is what? Root 5 plus root 2. Okay? Now we start with the multiplication. So if I multiply root 3 by root 5 into root 5, I will write it as it is so you can understand the steps. Root 3 upon root 5 into root 5 plus sign. So plus into plus. Root 3 upon root 5 into root 2 plus this number into this. Root 5 upon root 5 into, root 5 upon root 2 it is. Root 5 upon root 2 into root 5 and plus root 5 upon root 2 into root 2. So here I have just put the expanded form. You have done this bracket before, I put the expanded form. So what will we get here? See for yourself. Here this root 5 and root 5 gets cut. So what is left? Root 3. Here nothing gets cut. So root 3 into root 6, root 3 into root 2 is root 6 upon 5. Plus root 5 into root 5 is root 25. So root 25 is 5. So 5 upon root 2 plus, here the root 2 and the root 2 gets cut. So we are left with root 5. So multiply the two numbers you get root 3 plus root 6 upon root 5. Oh, there's a mistake here also. Root 6 upon root 5. Yes, the root has to be there. Plus 5 upon root 2 plus root 5. So this is multiplying the two rational numbers. Okay. So I hope it is clear to here till here. Is it clear? So now I'll write a few sums on the board for homework purpose. So kindly copy them down, do it and then forward the homework to me. These sums are your homework for the day. Simplify the following expressions. There is a plus, minus, multiplication and square, 4 simple. And from yesterday's work I given you, express the following in P by Q form. So you are given non-terminating recurring decimals, and what you are supposed to do, put it into the P by Q, that is the P by Q form. I hope you have understood till here. Do the homework. In case you need help with the sums below, then you can see the previous video lectures also. Right? So you will go through the lectures one more time and finish the homework. When you are done, you can send me the homework and keep practicing. You are doing quite good. I am very happy and very satisfied for your support that you are given me. Yes, and keep on practicing maths. Maths may look difficult to you, but is not difficult to at all. The more you will practice maths, the more you will know. Now one more thing, this kind of sums are asked in the IMO, ISO exams, mental ability and all. This kind of sums are asked in a huge number because this needs a little bit of calculation. So practice these sums well. If you have got another reference books, you can also try. Yes, this sum, when we'll make the material, I'll forward it to you also. But in the meantime, try these sums and do as many sums as you can. The more you practice, the more better you get at maths. Okay, have a good day. Thank you.